Hello, everyone, and welcome to Layer by Layer. Today, we're going to talk about what this is, how we screwed up our filament launch, and some of the news in the industry, including Sculpteo, BASF, and AnkerMake getting some nifty software done. So let's go ahead and get started with Layer by Layer. Let's go ahead and open up with news. AnkerMake has released a piece of software called CityPrint that allows you to select from several different cities and basically download an STL of that cityscape, which is actually a really cool model building software. It's cool to see the stuff that is not CAD-based software, but still allows some creativity. So there's really good access to good quality models out there. I'm glad a lot of 3D printing companies are starting to do that. It's on the roadmap for us a little bit too to help with clients kind of modify their files so they're manufacturable. But to have people actually making product creation softwares that are really easy, this is really great because it opens up 3D printing and 3D printed products to a lot more people. It's like having editing tools inside of Instagram so that you don't have to use Photoshop. It's a high enabler, so we're really excited about that. Especially how it relates to like our Etsy integration and that kind of stuff. Now, anyone who might not even ever use a 3D printer can create and distribute models that can then be printed by end customers. So it just gives access to a whole new category of folks who aren't very familiar with the 3D modeling process, which is really fantastic. So I'm glad AnkerMake is doing that. BASF is shutting down Sculpteo. The print-on-demand prototyping service of Sculpteo. This is totally understandable and unfortunate. It's totally understandable because print-on-demand services, prototyping services, are not very profitable. We have one. We have our print-on-demand app where you can just upload a file and get it printed overnight and that kind of thing, and it's not very profitable. Plus, if you're not highly certified or highly specialized, there's not a lot of value to it. So like Sculpteo was kind of for arty sort of plastic jewelry sort of stuff. They were in like that sand casting sort of low grade SLS kind of category. So it's not surprising that they weren't heavily used compared to if you were doing engineering, you do Xometry, and there's Chinese alternatives also. And then if you were low grade, you might just have a printer at home that really eats in that market share. When we did our print-on-demand app and continue to maintain it, the main point of it was to demo our V1 API so that we could test it and qualify it. And it's been great for that, giving all kinds of good data feedback on that for improvements for V2, which actually we'll talk about here a little bit in this podcast. But the V1 API was running on the print-on-demand app because that's like the simplest version of any app that can run on. Someone uploads a file, gets a cost estimate, and orders the file. That's the fundamental, most basic thing that anyone can do with a 3D printing service. So, but it's not necessarily a very good business component as of yet, and that's partially because of like the limitations of the original API that we built, which again we'll talk about a little bit later on. But that's kind of the main news there. Filament update and the I don't know which one of these to do first. Let's do filament update. Most of the people watching this are probably engaged with the tangled filament at some point. Whenever you launch a new product, there is always teething, always warts, always terribleness, and you try to minimize them as much as possible. But then there's that mole in the middle of your back that you didn't know was there, and then you go and strip off your shirt at the beach, and everybody recoils in horror. We had kind of that moment we got blindsided by something that we totally didn't expect. So all of our spools are shipped in a 9x9x9 box. That's fine, but the thing is, these spools, the standard size spool, this is an MC 008W, I believe, is the model number for this spool. This is a standard size spool. This is used across the industry by everybody as far as plastic spools. We're doing this for the initial launch until we get our cardboard spools implemented, which will be happening in the spring, which will also be a different size format. Anyway, these spools are an 8-inch diameter. They're going in a 9x9 box. The reason we use a 9x9 box is because it's the standard size that we use. A 9x9 box costs about 70 cents if you're ordering like just 100 of them, and down to like 50 cents or less if you're ordering hundreds or thousands of them. But and it's too big for this spool. The right size for 3 of these spools would be an 8 by 8 by 9. The problem is that that box costs about 20% more than the 9 by 9 by 9 because it's a non-standard size that people don't really use very often. So we have tons of 9 by 9 cubes around because that is what we use for shipping in all of our other operations and services because it's an affordable box that works all the time. But since you have that inch of gap, you have a 9-inch box and an 8-inch spool with about an inch on the outside here, these spools were able to shift inside of there. We knew that, but they were spools of filament. We didn't think the shifting was going to cause damage. They're inside of a nice square box. They're all tucked together. Everything's fine. And they're sandwiched well vertically. What we did not realize is that shifting would be so significant as to wear through the vacuum seal on these spools. The thing we didn't realize is that the main hub and the outer ridge of this is just slightly raised above the plane of the reel, just slightly, which means that when these are stacked together, these hubs are pressed together right there. So there's a stress concentration right there of all 3 spools sandwiched right there. And the only thing between them is the vacuum seal bag. And if they're really roughly handled, going through conveyors and around, and they're allowed to slide back and forth about a 1/2 inch, this wears through the vacuum seal bag. So we have had a number of folks reach out to us and say that their vacuum bags were compromised at arrival. And the reason is because these were able to move freely by 1 inch inside of the box, which, to be totally honest, we did not even consider as a problem with the vacuum seals and stuff that we were doing. The ways we're going to fix this is that we're going to go to an 8 by 8 by 9 box. It's not ideal because when we're chasing the $10 filament target, dollars and cents matter. You got to chase the pennies and the nickels and the dimes. So 20 cents is not a small amount compared to $10. Like that is a percentage point, a significant part of a percentage point of the cost of a thing. It only takes 5 more of those little things, and you've just made the spool $1 more expensive. But we got to do it. The short-term fix, we have batch 2 coming out. We might not be able to get the right boxes in time. For that one, we will put foam inserts in between each one of the spools so that there is a distribution and a separation that protects the vacuum sealing. But that is the main learning and the main issue that we had with the filament. So it shouldn't matter for PLA. PLA, you can almost dunk inside of a pool and then go put it on your printer and it's fine because it's not hydroscopic. So long as the ambient area is, the ambient area is dry. You're not printing in the rain. PLA is fine in humid environments and that kind of stuff. So it shouldn't be a big deal that the vacuum seals broke. And that's part of the reason that we started with PLA was to give us some forgiveness on this as we were working through this issue. So yeah, we will be fixing that going forward to make sure that spools can't shift around. And now we know. And, guys, this is the thing with like any business, especially something like this. Other filament manufacturers exist right now, but we don't know what they do because they have to and what they do because they're just doing it wrong. Because right now they're charging a certain amount for filament, which is clearly wrong because there's ways to make that more affordable. But they're also packing stuff in the right size box. But they also do that because that's the only thing they do. This is the challenge that we have of like, we are a 3D printing farm company and we've started making filament. So now there's this whole other business that is now being absorbed into the core business. And the processes don't mesh perfectly. So we have these growing pains. But thank you so much for all your patience. And thank you guys really very much for telling us about this. It is way better to have negative feedback than it is to have nothing. Obviously, everybody wants rave reviews and that kind of stuff. This is 3D printer filament. There's not going to be rave reviews. It's like, yeah, that printed. But the negative feedback is very good for us because there's no way to get better without people telling you what you did wrong. So bring it on. We're doing our best to get it all addressed and fixed as quickly as possible. But yeah, the vacuum seal bags are the main issue that we've run into. There haven't been too many others so far as we know. a few kind of weird things that are to be expected out of the number of spools that we shipped out. But overall, it's been a fairly successful launch so far, but y'all are printing with them, so let us know. The material, here's the thing that people didn't really realize, because it's in the description, but it's not really like we didn't highly market this. But the PLA that we made is not run-of-the-mill PLA. It's not cheapo PLA. It is NGO 850, which is performance or pro PLA, which means that it has a high heat tolerance and is a little bit different to print with. It uses PLA settings, but when it's done and the way we process it, it sometimes needs to be printed at a little bit higher temperature, like 220 to 230 range, rather than like 180 to 210, like you will do a standard PLA. I also recommend, if any of you are tuning your settings, to jack up extrusion width just a little bit, about 10%. This is something you should do with pretty much all materials, because the side extrusion, you don't want exactly the nozzle width. You want a little bit more than the nozzle width because the flow out smooths out the printing. So just printing tip there. But where was it going with that? Oh, PLA Plus. When this PLA is printed, you can anneal it, and it will be about as strong and temperature resistant as ABS. It also just generically has right off the machine, has a higher heat deflection temperature. So depending on what your design is, it can go in a hot car way more easily than standard low-grade budget PLA or PLA Plus. So that is a thing that a lot of folks didn't realize, and we didn't really promo on this. This material would generally be in the $25 to $35 range, and we sold it for $20 a spool in a pack of 3. So it's very good material. It is not bargain basement, recycled, garbage, low-grade PLA. It's very good stuff. So we wanted to pat ourselves on the back a little bit about that, because we did not give ourselves enough credit about that when we released the filament. But 850 we use inside of the farms because it has a higher clarity than 4043 or a lot of the other beads and that kind of stuff. So it is a cleaner clear than most PLAs, which have a lot more yellowing in them if you're not careful there. This has a little bit. It still has a tinge of it in there, but it is cleaner. So it has a better clarity and it has a higher temperature resistance, which is really nifty. And yeah, we didn't promo that enough because the main thing was we're getting the PLA batch out of the day. This is ultimately PLA, but it's really good PLA from a functional standpoint. Anything else? I don't think there's any other major stuff there. Yeah, I don't think there's any other major stuff there right at the moment there. But the PLA launch, yes, please continue to let us know. We're trying to respond to all messages and that kind of stuff, though, too. For all the feedback, you guys have been giving a lot of feedback. And by the way, for people out there who are being cynical, it's not all negative. People are just telling us how the spools are going. So just the general information of like, I printed on this machine, I did this and that kind of stuff. Those updates are fantastic for us to tweak stuff and continue to refine it. So please do that. We also are publishing how we're addressing different issues and that kind of stuff on the Tangle the blog, where we talk about like, here's print settings and here's this thing and this is something we ran up with. So like we talked about the solution with the vacuum sealing on the blog, because we're going to be, I think a fundamental necessity of this project is to be super transparent. Otherwise it doesn't work. Because so we're gonna bear our black eyes proudly in public, I suppose. Because number one, there's no shame in it. Yes, we have screwed up before, and we will screw up again because we're humans. We will do our best to fix those and move on with life. But it is impossible to have a perfect product on the first try. So we take our stab at it, we do our MVP, and then we go from there. The other learnings in the background that you guys haven't really seen as far as like the process management of this first batch was not smooth. I want to say it's smooth. It didn't roll off of the machines the way we wanted to, but it really informed format and style of how we need to go about it in future to make sure that the quality continues to improve. Because we want to up our quality right now, and the process that we have in place right now is too labor intensive and introduces too many opportunities for stuff to go wrong. So we're not going to get to $10 with what we're doing right now. So it helped us refine the details of the roadmap. We're still on schedule, and it doesn't ruin what we were planning with the master plan yet. But we will be working to get additional machinery in the new year. And by additional machinery, I mean another extrusion line that's optimized for like 1 kilogram spools or that medium range spool, because we work with large spools. We use large spools on our print farm almost exclusively. So consumer sizing, and also making sure that it's able to spool directly to that and that kind of thing. Because right now we use master spools. So we extrude directly onto a large spool, 50 to 100 pound spool, that coils up the filament, and then you take that big reel and you spool it down onto the small reels. The reason for that is because you're able to control batches, it packs much more densely, and the extruders are able to run more efficiently and more reliably because you don't have to have people pulling off single spools all day long until they get to the spooling station, where the spooling machines take them down. But the problem with us doing that multi-step process is that the reeling is a little bit loose, which we don't want to have to have continue to occur. We want to get that tightened up, but the only way to do that is directly off of the extruder. So we need a different type of winding machine, a slightly different extruder model, and yeah, just some upgrades throughout there, because creating a nice looking consumer product is going to be tough. It has to be all the machinery has to be focused on that type of product. Whereas down spooling for all different sizes, like we do in our industrial context, just doesn't work. We're able to deal with like loose winding and that kind of stuff because our systems are very robust. But an individual hobby machine might not be able to deal with it. And we don't want to deliver that quality product. We've always said with Tangled, like, we're going to be affordable, but we don't want to be cheap. There will be moments where we come across as cheap because we're going to try to stretch to the next little reach, and that might end up breaking something further up the chain. So when we reduce the cost, we'll like cut something out, or we'll try to put 3 things in a 9x9 box to save 20 cents, and it will end up ruining the quality of the product. So we can't do that. But we're going to keep on pushing it all. And fundamentally, there's a worst case scenario here of like, okay, what if we fail and we can't get to $10? That's unlikely, but what if that's the case? It is possible, just with the model of Tangled being built off the side of us, to where it improves the efficiency of our production, to where we're able to make a lot of filament both for ourselves and for for you guys. There's still an efficiency in there to where we can create a lower cost supply chain that's like $12 or $13. But then we got to pack it into a box with everybody else. And we're competitive, pack it into a box and do all the labor and that kind of thing. But then we're competitive with overseas manufacturers. And right now, U.S. filament manufacturers are not competitive. So we just want to make sure that we're pushing the industry forward. But yes, we're basically done with Tangled. Active work on Tangled here for the year. We obviously fulfill final orders and that kind of stuff. The second batch is going out on the 20th. But after that, we're going to be kind of dark through November and December because we're supporting people using our Etsy app, our existing clients, and just general Christmas in general, where we work with everybody making everything all the time. Everything everywhere all at once. Okay, so that is the filament update. Yeah, kind of a little bit of a rocky start there because our vacuum bags are breaking themselves in transit. We've got a short-term fix for that, a long-term fix to make sure it doesn't happen anymore, to make sure that things can't shift around. But beyond that, everything went well. Our vacuum sealer is working. Everything is working. We want to refine machinery overall. Super long term, even into January, we will probably focus very heavily on subscriptions, because one of the big cost saving components of this is to know exactly how much filament is needed. So we will probably have very limited runs that will be cheap, and you can get it while it's there, and it's effectively a sale, but we're not going to change prices. It's not like, oh, it's 20% off today. It's like, here's the price. This is how much of it there is. And when it's gone until next month, where we make the exact same amount again. And then we will scale up when we see, oh, we're selling out every time let's do that. But to guarantee that you can always get the spools will require the subscription. Darn. Hello? Okay. That. Alrighty, the filament update. So that's all that. Let's see here. Filament. That Anker. This is fun. This is really interesting. This thing. No. If I was a professional, this wouldn't be a deal. I would have pushed the button on the side of the phone right there, and that wouldn't have happened. But I'm an amateur. This thing. I was getting ready to do a big reveal. This is a force sensor. A couple weeks ago, we did a video around the dynamics of how different infills broke, because we wanted to show how different infills were like kind of three-dimensionally stable, how they broke along the diagonals, all that kind of stuff. And we didn't publish any of the numbers on that because they weren't relevant. We wanted people to see how it broke. So when we say you want to use diagonal infill on this because otherwise it's going to break like this and so on and so forth, or you want something more stable that has a good soft break dynamics. It's really important to know how stuff breaks, not necessarily the numbers where stuff breaks, because based on your design, the numbers will be different. So having the numbers for the cube is really irrelevant. But we heard you. We saw you all in the comments. This strain gauge, we got a hold of this to put inside of the press that we were doing with those other ones in order to do a nice detailed stress test. And there are more of those videos coming. But here's the thing, guys. While we were talking about this and taking feedback from that video, we were like, oh, wow, there's really, except for Stefan at CNC Kitchen, there is not really good analytical information, let alone YouTube videos, information around the dynamics of print settings and materials. And we can fix that because we do have a decent amount of testing equipment inside of the house or inside of the building, and things like this are not cheap. I mean, this is not this costs more than a printer to get good numbers for you in a detailed kind of a way. But those numbers are so necessary because right now, since FDM has been so consumer focused, no one has been held accountable. Because an individual user cannot tell when like a batch of color changes from one batch to another. And since most of us are doing kind of hobby sort of work, we don't really need like engineering standards about materials or the colors within them. So, and I had talked about this before with like the BS of PLA plus, because PLA plus is bull. But there's no way to like actually prove that. But we thought it'd be really cool if somebody did. So talking to the team, we want to get in a tensile testing machine, basically dedicated just to the YouTube channel and testing things like wall thickness, infill, material types, all the rest of it, and just getting hard data out. And we will accept, by the way, side note, we will accept sponsorships from filament manufacturers that want us to test all of their colors compared against each other. So if you are interested in sponsoring a video for filament, go ahead and reach out to us, and we will consider it. And we won't even put our filament in the video as an ad. We'll just compare your stuff, just for the data, to have the data out there. But the other component of this is that there's a lot of other tests to be done. There's tension testing, there's compression testing, vibration, UV resistance, thermal resistance, thermal cycling, overall fatigue, every infill variation, print type, extrusion settings, so on and so forth. All of that stuff can be very exhaustively tested. And we do want to build out a lab to do this testing. And we we'll certainly do a chunk of it ourselves, obviously. We're going to produce a few more videos around some of the basic tests of just like compression and tension and that kind of stuff. But we want to get the correct lab testing equipment in-house. because it's both relevant for the Tangled project so that we compare our material against other folks and verify it and give a quantifiable information about it. And it's also just very useful for the channel because no one else is covering this except for CNC Kitchen. And no offense to Stefan, but that is not formal. Those are not formal lab tests. You have to use standard dog bones and standards and everything else. And he knows this. Stefan knows this. He's a testing engineer. And a video has to be entertaining, but we can do it better. Just a little bit. We think we can with like formal lab equipment. We want to do formal lab equipment. We can't do DIY stuff. Otherwise it's good information, but it's not actually true. And it's also not something that we can like take to clients or anybody else in the printing industry who wants to say, hey, this printing is fine. So we want to do lab equipment. It's expensive. So the request that we have for you guys and kind of the comment of the day is half an hour into the podcast. Nobody's here by now. Nobody's still listening to this. There's no one still listening to this. But here's the request. We want to do a Kickstarter for it, where basically the Kickstarter prize is we will guarantee to produce 10 to 20 videos when we get this particular machine, and then stretch goals would be additional machines. So it's like $10 or $20,000, we get the tension tester. The next $10 or $20,000, then we get the UV resistance tester or vibration and so on and so forth. All these things. And we would start producing videos in our normal content cycle that are purely testing videos of like, here's the thing breaking, here's the level that it broke at. We tested every color of this brand. We tested every color of this brand. We tested all the different materials, all the different PLAs across each other, the different PLA grades. And we tested just the filament itself. We tested it in compression. We tested the infill patterns, just everything, so that we can say, if you print this material on this machine with this printer profile, this part will behave like this. Because right now there are no engineering charts and diagrams to say, I need the part to do this. How do I get there? You have to use trial and error. But we can start pulling together that data to where you can just say, basically a multiplication table of parameters and say, oh, I needed to have this resistance and this strength or whatever else it was. Oh, okay, 15% infill with 5 walls with the PLA from that guy. That is what it is. It's a true engineering, creating basically an engineering standard. So we want to do that. We really want to do that. But it is expensive, and we have a lot of fish to fry. And we got to build more printers so that our people get their parts out at Christmas on time and that kind of stuff. But we are going to try as hard as we can to get the tensile tester in ourselves. But we wanted to ask if you guys would be willing to help by like kickstarting part of it. And maybe we could do like a dollar match thing or something like that to make sure that we have skin in the game there. But it's expensive. And we would like to crowdsource it a little bit, especially if we are going to share this information publicly through the YouTube channel, which we think needs to be done because it is very useful and will help the industry grow as a whole. But it's expensive. And we just bought a filament extruder to make filament half the cost of what it used to be. So we need more help. But yeah, let us know if you would be down to like help out with a Kickstarter for like $10 in or $20 in or something like that to contribute towards buying lab test equipment so we can do good analysis of all the different material brands and really hold the manufacturers accountable of like, you said this was whatever material, but it is weaker than this, that, and the other thing. Of like the cheapest PLA is stronger than the most expensive. What's going on here? Like do those tests to where it's useful information that no one else is able to get done right now and doesn't have the time or ability to do. It is useful for us too. So again, there's kind of this dual purpose of like, we want to create a good video, but we also want to know ourselves in the context of running a print farm. So we're able to pay the rent and pay the people to operate the machinery, but the machinery is expensive. So if we can get some help, we'd appreciate it. So yeah, comment down below if you would be down for kickstarting this. And if so, we will try to get that campaign out pretty quickly because number one, there's not a lot to it. It's like, here's the machine we want to get. If we can get that machine, we can make 10 videos. You want to kickstart us? It's actually almost more of like a Patreon thing, but we don't want to do Patreon. Patreon's really cumbersome and not helpful. We communicate with you guys through the YouTube comments, and we don't know how to do exclusive content 3 days ahead of time. We don't see the value in that, so we don't want to do it. So anyhow, that's pretty much that. But yes, we want to build a lab to verify filament and settings and everything else so that you know that if you print it like this, this will be the result. We have the new video coming out around the ultimate strength of different infill densities. And we are going to do a few more videos around that to also show what is the thing that we're going to make for y'all. But we would like to get more formal testing equipment in there. My personal interest is in the fatigue. That will do it. All right, let's see here. What else we got here on the show notes? We've gone a long time. I know a lot of podcasts go for like 1 or 3 hours, but like when we hit a half hour, we've been going for a while. I whipped through this stuff. Okay. Awkward silence. No, we're not going to cover that this time around. API v2. API v2 is coming soon. If you're interested in the API for plugging into your own development project, reach out to us. The API, by the way, is for software developers. If you're not a software developer, it won't be much help for you. But we've been using V1 to power the print-on-demand app and our Etsy integration. So that folks can use our print farm to produce parts for their customers or teleport parts from Europe to here, basically. And thank you all for been using that, who have been giving us feedback on that project too. But V1 has been functional. V2 is really awesome. Like, the guys have done some good work on that to where we'll do an announcement video on it, talking about all the components of it there, but the API v2 is really, really good and will be sort of incredible for as far as user experience for you guys using it, because it's super fast right now. But yeah, we'll do an announcement video on that. But API v2 is coming soon. We'll be doing a similar demo test of it through the Etsy integration. So it's once we're done with testing of V2, it will be implemented into Etsy here in the next couple of weeks or so. So the Etsy app will be improving, and we'll get basically a version 2 makeover. And then after verification through there and everything else, and we get final little bugs out for developer interface and documentation and that kind of stuff and demos, we will release API v2 potentially as early as December, but we'll see on that. We might have to push it all the way to January based on how busy we are. But that is the plan right now. V2 is coming. It's going to be pretty awesome. There's a lot of cool features about it, to where we hope it will open up all kinds of resources for y'all who are wanting to build printing integration. So like if you have a nightlight generation app, you can now monetize that by actually having the lights printed very quickly and delivered. That kind of stuff. That's cool. It's really cool stuff. Or you can put like a buy now button inside of our 3D printing repo, so that designers could sell their models, the physical copies of their models, and not have to worry about it. That'd be really cool. So V2 is coming soon. And that's pretty much it for the show. So yeah, once again, guys, comment down below if you would be down for a Kickstarter on the lab testing equipment. We think it'd be a really good resource for the community, and we have a little corner that we have space to put that stuff in right now. We're getting crowded, but we have room for it, and we will be able to actually run through stuff and continue to publish that information here on YouTube so that y'all can see, oh, that filament actually is that filament, and that setting actually does help, and that settling actually doesn't matter. We can dispel some of these rules of thumb and just say, that is how it's done. That is the strongest infill. That is the best way to print this, yada, yada, yada. So yeah, let us know if there's anything else that's come up, guys, and hope to see you again next week. Have a great day, everybody.